Okay, your next challenge is called Find the Largest Number in an Array. And this is cool. This is starting to look more like a real problem you might encounter, even though we're still in the very easy category. Anyway, you are to create a function that takes an array of numbers and return the largest number in the array. So, our examples are pretty clear. If you look through these numbers, you can see that 5 is the biggest, and etc. for the remaining two. I think that's straightforward enough. So let's get on to the coding portion. Now's your chance to pause the video. Please think about this and try it out. That's how you're going to get better, is by doing these for yourself. And I'm going to align these curly braces because I have OCD and it makes me feel better. Now on to the solution. Let's start with, rolling our own, doing it all ourselves, so we can see what it looks like, and then we'll look at some of the built-in methods for doing this, which kind of do the same thing, but they just shield it from you so you don't see it. And it's a nice syntactic sugar, if you will, that you could just write a little one-liner and get some kind of looping behavior out of it. Anyway, let's go. This is an integer array. We're going to go int, and we're looking for the max. We'll just call it max. Int max equals. Now I got to set this to a default value, and I want to make it the lowest possible integer to start. And that way, as we read in numbers, something will eventually replace it that we read in. I want to start at the lowest possible integer value, so I'm not missing any values that might come from the array that could be lower. And imagine all of the numbers were lower. If I just started this at 0, and then imagine we had an array of negative numbers, it would come back that the max was 0, and that would not be correct at all. So I wanted the smallest possible value that can fit in an integer. I looked it up online quick, and there's this parent value here that we can use from the int32 class. So let's try that. int32 min value. Should be good. Now, I don't think we've used for loops before, so we're going to need that. It essentially allows us to iterate over the entire collection and examine each value one at a time in turn. So I'll explain the for loop in a second. We'll just write it out. To array.length I, and we're going to use these curly braces to define the scope of it, meaning that anything within these curly braces is going to run for each loop here. Now you notice the loop has 3 separate statements. It has an initialization step, it has this condition we check for terminating the loop, and it has an increment step. So we're just calling this I. That's a very common practice just to use for an index, is just to use the letter I. We're going to start at 0. Remember, arrays start with element 0 and count up from there. They're 0 based. Then we're going to look against the length of the array. We want to go over all possible values. So we're starting at 0, and I'm saying not equal to the length. You often see this written out as less than the length. And that's fine, because the length would be 1 too many. Remember when we talked about arrays, if you have 9 elements and you try to access element 9, it essentially crashes, and you need to use index 8 if you want the 9th element. Anyway, so that covers us, so we stop at the end of the array. Then each time this plus plus, we did a prefix and postfix video, so hopefully you've seen that. This will just increment I by 1. It's like writing I plus 1. So you start at 0, next time through the loop it'll be 1, next time through the loop it'll be 2, all the way up to whatever the length is of the array. So we know this is going to execute each time for each index value starting with 0. So what we're going to do is we want the array element at this index, right? Array I will give us whatever element is there. The first time through this loop it'll be array 0, it'll give us the first element. And what are we going to do with that? Well, we want to compare it against the current max value. And if our current number that we're looking at is bigger than the max, we want to say, hey, we have a new max. Let's update this to get an accurate representation of our array. So let's go if array I is greater than max, we'll say set the max to array I. And that updates it. And so this will go through, it might encounter some lower values, in which case this if statement won't be true, and it'll just kind of skip and keep going through, keep looping in the for loop. Every time it pops, you're gonna get a new max and update it. By the time you run through this for loop, that max value is gonna have the info that you want in it. So we can simply return max once the for loop's done. Notice it's done outside this closing brace here. So I think this is good enough. We'll see. The moment of truth. Uh-oh. Did something bad here. The name of the does not exist in the current context. Oh, I probably needed to... Oh, let's add this. See how they have this using system here? I think we needed that. Remember, if we use code that we don't define ourselves, we have to bring it in from somewhere, and that's what these using statements do. This will bring in the code we need to recognize this, because right, we didn't make this. I didn't define any constant for min value, so we're bringing it in here. You can get a lot of other things here, and so let's see if that works. Okay, that's better. Yeah. And you'll note that we had no sort of guarantees about the input that it would be sorted. Remember the instructions, they were randomly placed. That would be quite handy if this thing were sorted, right? We could just take the last element, assuming they were going in ascending order. That would make the last element the max value. And we could do something like that. I don't think it wouldn't be as efficient, but certainly if you just want to write a line or two of code, we could do that. And it might be useful to go through that version as an example. Let me refresh to clear this, show you what I mean. Code, okay, ugh, why? Okay, so now there exists this array class that you can check, and it's got this handy sort method with it. Don't be scared yet, but there are tons of overloads that look awful when you see all these variations. I just took a very simple one, try and keep things simple, where it just takes the array itself and it sort of does some default stuff that what you would expect, especially in the case of integers. So feel free to use that reference and read through that. We'll go back and we'll use it. We should probably note namespace system, so I think we got that. Oh, not since we refreshed. Let's use using system again. Then let's take array, call the sort method and pass our array in, right? That's what it said on the document. Now this should sort our ARR array when it's done. Then, like I said, if you do this, you can simply return array r.length -1, the last element, right? Because they're sorted in ascending order. So if we try this, hey, there we go. See, that's another way. I like the first way better because we go through the collection once, and so the complexity would be O of n. We'll talk about complexity later, but it has to do with the running time of your algorithms, and you want to keep that value down, because even though we're doing examples with collections that hold only 3 or 4 elements, in the real world they could have many thousands or millions or more. So this is quite important when you consider the efficiency of your algorithm. If it has to go through a collection multiple times that has millions of entries, you're going to be waiting a really long time and it won't work. So that's one way. I just think this would be less of, it does a lot more work than it needs to do. We didn't need everything to be sorted, right? This is doing extra work. We just only care about the maximum value. But it shows you, many ways to skin a cat. There's another way you could do it like this. And then they have also, let's do it this way. Let's refresh. We'll use a bit of syntactic sugar here. And we're going to bring in another namespace using system LINQ. I think that's what it's called. And we're going to go return grade max. Does that do it? Let's check. Yeah, there it does. And there's your magic. There's this LINQ class. LINQ, I think, stands for Language Integrated Query. It looks a lot like, if you've worked with databases, it reads a lot like that. Let me see, I had a Stack Overflow here. Kind of along the same lines. They were looking for a max value and a corresponding index, which we didn't do, but I just wanted to show you. This is the kind of stuff you can do. If you've worked with DBs, you recognize very much. Like SQL, you recognize this kind of syntax. But yeah, it's kind of handy for working with collections of data. But keep in mind that there's no magic here. Underneath the hood, they would be doing something like we did originally with going over a collection. So don't think that this is just automatically worlds faster. But it is very nice and clean, right? I mean, man, it doesn't get more succinct than that. That's pretty sweet. So, yeah, there you have it. Multiple ways to do it. Check out LINQ for some other powerful features. Yeah, so you could look into the max method right here if you wanted to understand that some more. As you'd imagine, they probably have a minimum select, so you can do all sorts of crazy stuff. But yeah, I think that covers it. As usual, questions, comments are very welcome. Thanks for watching.